Yes, good evening and welcome back to GBS lecture series. Once again, I'm picking a question from mathematics for all our children, and this question is actually from I picked the question actually Western Province, the Department of Education, Western Province, first term, Maths paper part 2, paper 2, part A, and question number 4. Let's work it out. From the following figures, the area of the rectangle is 3 centimeters square less than the area of the trapezium. Now you can clearly see here, we have one rectangle. And then we have one trapezium. 3 centimeters square less than the area of the trapezium. All the measurements shown in the figures are given in centimeters. Using these information, build up a quadratic equation, and by solving it, show that there exist two different values for the area of the rectangle. That's what we need to calculate. In doing that, first we will jot down the measurements. Now they clearly said that these are 90 degree. Obviously it should be because it's a rectangle, and the height is given as x minus 1, and length or width is 2x. This is the length, and this is width, and this is length. This is the measurements for rectangle. And then they also gave us the measurements for trapezium. This is x minus 1, and this is 2x plus 2, 2x plus 2, yes. And the diagram is slightly like this. And this is the vertical height. The vertical height, perpendicular height is x. Right, now we need to know some basics. What the basics we need to know? The area of rectangle. Area of rectangle is equal to if you have a rectangle like this, the area is the length into the breadth. So this is all 90. So the length of this diagram here is 2x into the height or the breadth is x minus 1. This is the area of diagram A, let me say. And diagram B is trapezium. The area of the trapezium is area of trapezium half into the total of this length and the total of this length into the perpendicular height. So what is the total of the first length is x minus 1. So x minus 1 plus the total of the second length is 2x plus 2 into the perpendicular height is x. So this is the area of the trapezium. Now let's simplify both. If I simplify the first one, 2x square minus 2x. That is the answer for this. What you need to do actually, you need to multiply this 2 and then you need to multiply this 2. If you multiply first one, you get 2x square, and the second one minus. Here, because the sign here is minus, here sign is plus, so minus into plus minus, 2x into minus 1, 2x. Let's simplify the second one here now. The second one is actually half into, let's first simplify this expression within the bracket. So let's expand the internal bracket. X minus 1, here plus x, here minus 1, here plus 2x, here plus 2 into x. So if you do that, half into, so here plus x, here plus 2x, so it becomes 3x, and then here minus 1, here plus 2. So you see, when I have minus 1 here and plus 2 here, when I combine this, and that becomes plus 1, because the minus 1 is smaller, plus 2 is greater, plus 2 minus 1 becomes plus 1 into x. So let's further expand this, half into 3x square plus x. So that is what the area of the trapezium. Now what the question says, let's go back to the question. From the following figures, the area of the rectangle is 3 centimeter less than the area of the trapezium. So now we know what is the area of the rectangle. The area of the rectangle is this. So that is equal to 2x square minus 2x is equal to half 3x square plus x, and if you subtract 3 from here, you get that. This is what the expression that the question has said. Now what shall we do now? We will simplify this. See, I will remove this 2. In removing this 2, I need to take it out of away up other side of the bridge. So here we have a bridge here, equation mark. So then we need to multiply by 2, and also we need to multiply this by 3. Otherwise we call this using the mechanism of LCM. So in doing that, so what shall happen now? 2 into 2x square minus 2x is equal to 3x square plus x minus 6. So 2 into 2x square is 4x square minus 4x is equal to 3x square plus x minus 6. Now what shall we do? Now what we will do is that we will remove this to this side of the equation. So if I do that, 4x square minus 3x square. So minus 4x, and then again what I will do, I will remove this to the other side of the equation. If I do that, this plus x will become minus x. And also note that this minus 6 also I will bring this side of the equation. If I do that, that becomes plus 6, and the answer is 0. Now we will simplify. So if you combine these two, the answer you get is x square minus 3x square plus 4x square. So answer is plus x square, and then minus 4x minus x is minus 5x, and then plus 6 is equal to 0. Now that we got a very simplified equation, we can simplify quadratic equation using different methods. But first what you need to try whether we can use the factoring. You see, in doing that, in front of this x we have 1, and that is plus 1, and then we have here 6. So what you do is you multiply these two. So when you multiply these two, you get answer is 6, and then you need to write down all the possible factors for this. 1 into 6, 2 into 3. So this also 6, this also 6. So we then have to choose a combination or a pair that is suiting to this expression. When I extract or split minus 5x, and then I must get a suitable combination. That combination is this. So therefore x square minus 3x minus 2x plus 6 is equal to 0. Then what you do? Then we factor x minus 3 minus 2 x minus 3 is equal to 0. X minus 3, x minus 2 is equal to 0. Then x minus 3 is equal to 0 or x minus 2 is equal to 0. Accordingly, x is equal to 3 or x is equal to 2. See, now we got two positive answers for x. When x has two positive answers, then the area of the rectangle will have two answers or two values. Right, thank you very much for watching this mini video. Similarly, I will continue sharing some more questions which will be useful to all the students who are planning to appear for mathematics for this coming 2021 December, or hopefully the government will conduct the exams in December or in January. All the best and thank you.